Okay, so for z-scores, what z-scores will do is to help us with the in-between places, where I'm going to do this and do the mean, and this is 1 standard deviation, minus 1 standard deviation, and so on. So let's take, for instance, and something where, let's say, the average of some data is the number 700, and a standard deviation of 100. So this is going to be 800. This will be 900. This will be 1,000. This will be 600 because we're going to subtract 100. This will be 500, and we go out to 400. So you now know how, 1 standard deviation away would be 800, and so on. What z-scores do is they help you find the numbers in between. So for instance, let's take the number 850. 850 is in between here. It's like 1.5 standard deviations. Okay? So what we're going to do, I'm going to use this to show how to find out how to use it, and then we're going to do a couple of examples using that to answer some questions to find the amount of the percentages when it's in between standard deviations. Okay, so the way this is set up, you find a z-score, you find a particular number, and then you'll use this to find the percentage of the data that is below that place. So what we're going to do when we find 850, we're going to find the percentage that's below it. If we were right at the norm, 50% is below it. If we were at 1 standard deviation, we know that's going to be 34%, so 50 plus 34 is 84%. So we know that's 84%. But when it's in between like that, you can't use those percentages. You've got this extra amount here, and that's what the z-score will tell you. So what these tell you, and this is where you see x with the line over it, so that's the mean. This is the other one that's used for it. And I just put both up because you'll see it in different websites and different books either way, so you get used to it. So what we're going to do is to find, and I'll just do z. The z-score will be equal to the number we're looking for, or the number of the data, 850 I chose, minus the mean, divided by the standard deviation. So 850 minus 700 is 150, divided by 100, that gives you a z-score of 1.5. That's how you find the 1.5. Now, what we're going to do, and I'll tell you why we're going to put that. I'm going to put the 0. You usually wouldn't need to do that except for like if it's money in that sense. But in this case, it actually will be valuable. So now let's take a look at the z-score table. You'll notice you have 2 sides. One of them for negative, and that means it's for the numbers that are on this side of the table, or of the normal distribution. And on the other side, you have the positive one. So the way you use it is you're going to look down here at the z-score, but it only gives you the first number after the decimal. Now we're looking at 1.5, and then there's all these. If it's 1.50, which ours is, you use this column. If it was 1.53, you would use this column and you'd have that number. But ours is this, so it's 0.9332. Let's write that down.
Will we use this paper on the test?
Yes, and I will provide it for you. You need to memorize some things, but I don't think I'll need you to memorize the z table. So the 0, did I get that one right? So we're going 1.5, and so it's that one because it's 1.50. Well, that's a decimal. My question is, what percentage of the data is below 850? That would be 93.32, 93.3, or just round it to 93. 93% would be probably adequate here. If it was 0.4, 0.6, I'd probably call it 0.5, or just leave it at that. So approximately 93% of the data is in all of this area here. This, now notice I'm focusing on the fact that it's all of it leading up to 850. If I wanted to know above 850, this doesn't help you directly. You have to find this number and then subtract from 1. You'd have to find the difference going up to 100. So all of this is 7%, because that's what you need to get to 100. This doesn't give you the positive. This only gives you the amount that's below it. That's why on the top of these tables you see this. So all of these numbers are telling you it's all the data that's below whatever your z-score is. And on the other side, on this one, it's telling you the negatives, and it's the same idea, it's the one below it. So if you want to know above, you're going to have to subtract from 100. Okay, let's do that with this. A data set has a mean of that and a standard deviation of 8. What percent of the data is below 80, and what percent is above 80? Notice the steps for this are not hard. The first thing you'll do is do the z-score. The second thing you'll do is use the table. And then for this one, the third thing you'll do is subtract from 100. So let's do it. First one, z is equal to, go ahead and set that up yourself. Put in the number that we're looking for. Okay. Put in the mean, and then put in the standard deviation. And then use a calculator and divide it. So you should be seeing that. Now that's a nice long enough decimal for us to talk about rounding there. Right? So you should have gotten this one equals negative 0.71875. You noticed on the z table, on the side, it goes to the 10th place, and on the top, it goes to the 100th place. So that means we don't need these, except for the fact that the 8 is going to make that 1 into a 2. So you do need to use rounding. Because if you just did 0.71 and found a number there, it would not be as accurate as using the 8 to make it a 2, because it's clearly closer to 0.72. So that is the z-score you're going to use. So that's what you want to do with rounding. And then when you look at it on the table, second step is to use the table. So negative 0.72, you should have come up with 0.2358. I'm going to verify it myself here, but that's what I found out before. Let's take a look. 0.72. So here's 0.7 negative, and this is 0.1, and that's 2. Yep, 0.02. And that means, let me circle it on here, 0.2358, and that's what I got. So it's 0.7 going out that way, and here's the 0.2. So that's what you mean. Simply a percentage, 23.58%. I would probably just round that to 23.6. That's so much in the middle that I probably wouldn't make that 24. You could get away with probably saying 24, but 23.6 is probably the most reasonable here. So the percent of data below 80 is 23.6%. And above 80, well, subtract from 100. You don't need to write that in your head. 76.4. I do that all the time, which is why I catch myself now. And then I check, makes it 100. Okay. So one of the interesting things here is that 80 is pretty close to 85. You would think, okay, if 80 is close to 85, then the percent below should be not that far from 50%. You know, I would have thought like 42%, 45%, because 80 is, pretty close. Instead, because of the way a normal distribution is, so much is clustered right around the mean that 80%, if I drew it out, 80% is very close to the one standard deviation. It's like such a high percentage above it that it's not really that much. So I would have thought reasonably that should have been like a 40-something%, but clearly I wasn't thinking that way. Means I don't realize just how much is clustered close to the mean. And that's what this helps to show you. Any questions about how to do this? Okay, let's look at the page 2. Now, actually, page 2 and page 3 are done the same way as that first problem. So I'm actually not going to, I'm going to let you, if you want to, practice those, do those yourself, because page 3 and page 4 are different types of problems. So let's do the first one on the page 3. Let's do this one, example 1. So you'll still get practice using the z-scores, but now you'll do it with a couple of variations. And then you go back and practice the others on your own. So my height is 5'9½", my son's height is 5'6¼ I did this question a year or two ago, maybe a year ago, and that actually is my height, and my son's height is now probably closer to about 5'7". He's gotten a little bit taller, not that much, he does these spurts of growth. But I'm going to stick to this problem here. So I figured we'd make some good problems. In a normal distribution, American adult males have that height, and I think we'll stick with the inches because this is much harder to work with. I wish we'd switched to the metric system because it would have been so much easier to do everything in metrics. Standard deviation of 2.25%. Now, you don't really have to do one of these. I like to do it most of the time, but here with z-scores, you really don't need to. All you really need to do, I'm going to put me, let's figure out my z-score. In fact, I will talk about the idea here of what's happening. I think this would be good for it. My height, if this is the norm, oh, I can't draw that very well. Here's the norm. My height is a little bit below it. My son's height is significantly below it. Okay? So what we're looking for is not the amount below or the amount above, but the amount that's in between the percentage of American males whose height is between his height and my height. So we're going to have to find how much mine is, how much his is, and then subtract them. Well, using the standard deviation. So the z-score will be my amount, my 69.5, subtract the mean divided by the standard deviation, 2.25. So somewhere I wrote all this out, so now I'll write it again. Yep. So remember that formula that the z-score is whatever the x is minus the mean divided by the standard deviation. There, got that little symbol decent. So that is approximately negative 0.222 and so on. That means because these twos won't affect that one, it's just going to be this one for my z-score. But I have to use that z-score. So what I'm going to do now is go over into the z-scores, and I'm going to find what my percent is. Percent of people who are shorter than I am, negative 0.22. So negative 0.2, and this is the 2 column over here. So 0.412, whoops, I wrote it up, 59, 0.4129, which would be 41.29%. Well, 0.29 is like 3, so that should be 40, the paper is, let's write this so 41.3%. So 41.3% of American males in the United States are shorter than me. Okay, that's not too bad. I guess I'm a little below average. I'm a math teacher, I'm above average. I have a shirt that says that. I should have worn that one today. Okay, now, my son, whose name is Stephen, by the way. Well, I actually used his height, like I said. His z-score is 66.25 minus 70 divided by 2.25. And when you divide all that out, his comes to negative 1.67. Now, it's actually negative 1.66 repeating, but since I only want to go 2 decimal places, that 6 will make this 6 into a 7, so we'll be a little closer to what's real for it. Okay, now let's find his z-score on here, negative 1.6. So there's negative 1.6, and I'm going to go along here 2, 3, 4, 5, 6, 7. So let's go up, make sure, yep, 0.07. So he's at 0.0475. 0.0475. So that means move that over, it's 4.75%, which is like 4.8%, that we round to that. So I'm going to subtract these two. So the last part of this is just simply 41.3% subtract 4.8%. That tells you he's barely at the 5th percentile in height for American males. Now, he's only 15. So all adult American males are going to be mostly taller, so it actually sort of makes sense. So most of you have not reached your full growth yet, so you would be in the same place. You know, you would be a little low. Some of you are pretty tall already, you know, tall dads, but my son actually, being in the 5th percentile is actually great, because he was born 11 weeks early and was really tiny, and until he was about 6 or 7, he wasn't even on the charts for the height and weight. And in 9th grade, they did his high school PE, did one of these things where compare your weight, figure out what your body mass index is. He couldn't, because the charts that they had, he weighed too low to even be counted. Their lowest amount for a boy was like 112 pounds, and he was 106. So they couldn't even include it. So he has no idea what his body mass index is, except he's like a twig. So I think he's really, really tiny. He's tall now, but he's got no meat on. Anyway, enough about that. The percentage here is, or figure it out, 36.54%. Oh, I did it. It's actually, I did the ones. It'd be 36.5, isn't it? 4.8, yep. So it's 36.5%. So the math part of this is, when you figure out one and you figure out the other and you subtract them, you get about 30, almost 37% of the people are in between these two people, me and my son or anybody else who's like this. So that means this amount here is about 36.5%. The problem underneath is just like it. It's a company closing stores with the lowest profit and enlarging the stores that have higher profit. So I'm not going to do this one right now. I'm going to recommend you, do this as a practice problem, and I'll show this tomorrow. But the idea is the same. You're going to need to find out what the percentage is, or what the z-score is for one and for the other, and figure out what's in between. Because the question is, what percentage of stores will not be affected? They're not being closed and they're not being enlarged. So it's really the same concept of this. Okay, let's look at the third problem, or fourth page rather, the third type of problem. And this one's determining an amount. We're going to go in reverse. So what you've seen so far is how to use the z-score to get a percent. Now, and from that to get an amount. Now we're going to take an amount, because you're given the amount on it and you use that. Now, we're going to need to find an amount. Let's use this one. A distribution of SAT scores in a past year, approximately normal with, good, we know our mean, and a standard deviation of 318. Good. A summer program only accepts students in the top 10% of SAT scores. Okay, so what score do you need in order to get into that? So let's figure that out. So what that means graphically like this is 1483 would be here. We're going to go up 318, up 318 again. But you have to figure out, because these numbers don't get to 10%, we've got 34, 80, let's see, now 95% comes to about here, but we want 90%. So we can take the 10%, that's an in-between number. So what we need to do is find the z-score for where 10% is, and then from that get the number. So the z-score is equal to the x minus the mean over the standard deviation. Well, the problem here right now is we know this and we know this. So z is equal to x minus 1483 over 318. We don't know that amount. We need to know that. What's the score there that you would normally subtract from the mean? We don't know the z-score either. If we knew that, we could just multiply by 318 and add 1483, and we know what x is. So let's figure out how to get the z-score. Right? So we know the top 10%. Take your positive, the other side of the z-score table. I know they call it the standard norm cumulative it's the z-score table. I am not going to say this every single time. So what we can do is just find where 90% is. Because think about it, you want to know the top 10%, you really need to go where it's 90% below it, and then that number will be where the 10% starts. So let's find 90% on here, or 0.90. 0.9s, 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 0.89, and it looks like right here,
Wait, wouldn't it be 0.9?
yes, 0.9. I just said 0.9. So because we're looking, that would be 90.15% and 89.97%.
Oh, on that side, I was looking from like this side.
Oh, yeah. No, and that's the thing. Now we're going to do it opposite. We're going to find this and then go back to the z-score here. Is it? Oh, no, I
But
forgot.
wouldn't it be like 6.9?
Yes, we need that percent. We need the z-score number in order to put here in the formula.
Yeah, so wouldn't it be like 0.8151?
And 0.81?
Like,
Or 1 point, well, actually, first let's look at this. You have these two here, and 8997, so that one rounds very close. That one's only 0.0003 away from 90. This one's a little bit above 90. We should use this one, because it's closer. That one is the 0.08 above, but it's 1 point.
oh, I was looking at that, like on the left side, 0.9.
Yeah, that's what I was doing.
Yeah.
Point nine. Oh, this one?
No, on the left. Oh, where it
On
says
the
Z.
left.
Anything that I see,
On
I
the
was like,
Z
Z
Z
side,
0.9.
we were all looking on that side.
On
Going
that.
On 0.9, like go
going
up.
from 0.9 to 0, 0, like how we found that.
Oh, okay, okay. You were looking on these.
Yeah.
Yeah, I see what you're saying. And actually, that's part of the lesson, to realize that going backwards, you were doing this before where you used these to get a number in here. Now you're using a number in here to go backwards to here to get this number.
Oh.
So that's part of the thing here, is we're going it backwards. We're doing it in reverse. So good, I'm glad that you see it that way now. So if this is the 90% or close enough to the 90%, we're going to go and use the 1.2 and then the hundredths place, so it's 1.28. So back here now, the z is 1.28. Now you have an equation with only one variable. This is one of the basic things you want to think about in doing math at every level that you do it, is if you need to figure something out and you have equations that are part of this system, the thing you're doing, if you can get enough information to fill in all of it except for one variable, one missing thing, then you can solve it for that one variable. And that's what we did. You were given this and given this. We figured this out using that 10% and thinking about the fact it had to be the 90% of the z-score. Now, multiply by 318, both sides by 318, and you get, I had it figured out here, so I'll write it out. Yeah. 407.04. Well, that .04 is not really going to help us, so we don't need to use that. That's too far from doing any rounding. So I'll cross that out. Minus 1483. Add 1483 to the 407, and so x is equal to 1890. Need a score of 1890 or above. Yeah, it's a high score. That's the 10% mark is really high on there. Although these numbers are out of date and they change things, so I pulled this years ago and plugged in numbers like that, so I don't know for sure what 10% would do. It changes every year anyway, because of the students doing it. So what this one shows is how to go backwards on there. The problem underneath it does the exact same thing. So I recommend to try this one and do the same thing, because look at it, it's going to give you a mean and a standard deviation. But in this idea of reading scale scores in a 4th grade, the students have to have a score lower than, in the lower 40%. So you can use that 0.400, use the chart to find the number, the z-score, and use the that z is equal to, and these two are given to you, find the z-score, and then you solve for the x, just like this problem we just did. Yeah, now, so let's review this on here. On the first page, we did a basic problem. You had enough information to get the z-score and then use the z-score to get the percent. The next two problems are just like it, so practice those on your own. You don't have to, but if you do, this is a good thing to practice. I would recommend it. And then the third page was where we're looking for an in-between amount between two of them. That's just figuring out two percentages and finding the difference between them, so that's not really that hard. It's just we're recognizing what to do. And in this one, it was going backwards, where you're given a percent that you can go into the table and get the z-score in order to solve this for one missing thing. Okay, so practice those. Those are three types of problems. Two of them will be on the test. I won't tell you which two, just three types of problems. So you can see of the 7 that are on 1, 2, 3, 4, 5, 6, 7 problems here, they practice three types of things. That way you can be comfortable with understanding now what a z-score does and how to use it. So you know how to move around it and the positive and the negative side. Yes?
Are you gonna give us a study guide like you did last time?
I haven't decided.
Alright.
Depends on how good I feel this weekend. Actually, I am planning a couple of things. Some of the things that you do in some of these sections involve some really big problems that take a long time to do. So what I'm contemplating doing is giving you a couple of them as a take-home part that you can do at home, and then do the other things here in school. I can't say for certain until I finish making up the test, but I'm leaning to that very heavily right now. So if I do that, I will email you and I'll tell you all the information about it.
So there's a chance we might get a study guide?
Well, I don't know if I'll give you, because this time you actually had 3 study groups as opposed to last month where I went away and didn't bother to help you for too much time. Didn't have much choice, but. So you may not need quite as much of a study guide. But everything that we did in class, all these papers, is, if you think about it, a pretty direct study guide towards the test too.